Hello students, this is Mr. Bornheimer. This is going to be our second video on motion. So this is going to be Unit 7, Lesson 2. And we are going to take a little bit of a strong, a deeper dive into how we analyze how things move. So, in order to do this, we have to introduce some terms, and one of the terms I want to introduce right off the bat is this term called the origin. Now, origin is kind of a fancy word for starting point. So if you think about it, where are your origins? Well, maybe your origins here are here in Fort Wayne, Indiana. Well, we think of the word origin as being starting point. So we are going to start with an object that is here, and we are going to say that that object goes 1 meter, so it starts at 0 meters, travels to 1 meter, then travels to the 3 meter mark. So if you think of this as kind of like ticks on a ruler, okay, we have 0, 1, the 2 meter mark would be here, the 3 meter mark, okay, and then the object is going to go all the way out here to the 6 meter mark. So this object is traveling, okay, and it passes the 4 meter mark, the 5 meter mark, like I said, like marks on a ruler. So here we have an object that has moved. If we give each of these points a label, so we call this point A, B, C, and D, we can start to kind of define where this object is. And A could be like, these don't have to be A, B, C, and D. A could be for, a person starts at the bakery and then travels to, the hardware store, and then goes to the grocery and then travels home. Okay, so, when we think about describing motion, when we oftentimes are doing this in our own lives, we're doing it with physical locations. And you know this, if you're trying to give directions to somebody, say, hey, at the big water tower, make a left and go down to the 3rd Street on the right, and then take a right, and then go down past the blue house, and there you'll be at my house, right? And so we use landmarks to describe how things, and we always say, we always assume that there's a starting point for how we're moving. So we can describe this object's movement, okay, kind of like this. We can actually describe it. We can say that the object moved 1 meter from point A to point B. Okay, so we can literally kind of state the obvious and give some information about the problem. We could also say something like, we don't have to describe the whole thing, but we could say the object moved 3 meters from point C to point D. Okay, so we can describe various points of motion when we are looking at this object. Another way to describe how an object moves is to take this same idea, but instead of it being more like a timeline, because this is more like a timeline, okay, we can start to look at it in terms of a graph. And that's really the main focus of today's lesson is how do we graph an object's motion. So to get kind of started with this, I'm going to draw a little city block or some city blocks. Okay, so, and I want you to do kind of the same. Okay, so draw Okay, I know this is taking a little bit of time, but this is going to be a really good example for us to kind of gather some data and graph that data so we can see what does it actually look like when we are describing how an object moves on a graph. All right, so let's assume that a person starts down here. Okay, we are going to use your standard compass rose, so I'm going to draw that up here in the corner. Okay, so I'm going to give us a compass rose here. And that compass rose is going to be north is up. And typically when you're looking at down on a map, okay, and you're looking at this like I'm looking at it, you know, east is to your right, west is to your left, and south is down. Okay, so first things first, okay, we're going to say that this person traveled 1 block north. Okay, so they're traveling 1 block north. And then they made a turn to the east, like so. And then they go north again. And then east, another block. And then 2 blocks south, where they stop. Okay. Now, we need a little bit more information. So, I'm going to give you some information about each leg of the journey. It took them 1 minute to go north. It took them 5 minutes to go east along this route here. It took them 10 minutes. It took them 1 minute. And then all the way down along this edge here, it took them 2 minutes. Now, if you were actually watching this person do this, it would be kind of silly, right? And we're going to assume that these blocks, okay, are 10. We're going to assume that the blocks are, we are going to assume that they're very small, okay? And so that they're about 50 meters on a side. Okay. Now, notice that I have to be very careful about my units here. If I'm dealing with minutes and meters, I need to make sure that I'm very clear about which one's minutes and which one's meters. Okay, so there we go. All right, so this person is traveling through some city blocks, and we want to gather some data about that motion and put it on a graph. The best way to do this is to look at how the person has moved over time. And so what we're going to do is we're going to plot what's known as distance and time. Now, you don't have to copy this. I'm going to copy this because I've got to move to a different page here. So I'm going to put this here. I'm going to shrink it a little bit so it's easier for us to see it. And I'm going to, you don't have to copy it, but I'm going to create a table here. And this table is going to have information about time and distance. So how far the person is traveling over time. Okay. Now, when it comes to time, even though I have 1 minute and 5 minutes and 10 minutes and 1 minute and 2 minutes, even though I have all of those, I need to look at what's happening time-wise, minute by minute. Okay, so the way that this works when I'm building my table is that I say, okay, where is this person at 0 minutes? Where is this person at 1 minute, 2 minutes, 3 minutes, 4 minutes, and I build it up. So 5, 6, 7, 8, 9, 10. And what you're going to see is that we basically have to go all the way up to the total amount of time. So 1 plus 5 is 6, plus 10 is 16, 17, 18, 19. So we're looking at roughly 20 minutes worth of data. 11 minutes, 12 minutes, 13, 14. This seems kind of silly at first. 16 minutes, 17 minutes, 18 minutes, and 19 minutes. Okay, now, when I am going through and saying how far the person moved, okay, I have to kind of look at my 50 meter mark. So here at my origin, my person had moved at 0 minutes, 0 meters. Okay? And after 1 minute, they had moved 50 meters. Now, this is where it gets a little funny. I don't really know where the person was at 2 minutes, or 3 minutes, or 4 minutes. I don't really know. All I really know is that at the end of this 5 minutes, they had gone 50 meters more. So after 1 plus 5, 6 minutes, I know that the person has gone another 50 meters, which would be 100 meters. So again, over here, this is the total distance the person has traveled up to that point. So after 1 minute, they had traveled 50. We don't really know at 2, 3, 4, and 5, but at 6 minutes, we know the person has now traveled 100 meters total, because they've gone 50 plus 50, okay? And then we really don't know anything until another 10 minutes passes, at which case we'd be at 16 minutes here, and we put 150 meters, okay? And then we know that they travel 50 meters in 1 minute. So at 17 minutes, we know that they're at 200 meters. And then 2 minutes later, all the way down, they go an extra 100 meters. And so now we know that they're at 300 meters after 19 minutes. And yes, it's okay to have a time scale here that has blanks in it. Your tables that you will do in class next week, they won't have quite as many blanks in them, but it's important to understand that when we're trying to figure out how something's moving, we only can fill in the information that we have. And so in this particular situation, we fill in the distances that we have and the times that we have. Now, we always do put the times down like this over here because we want to remember that time is an ongoing thing. It always keeps going. Like right now, time is going. It never stops. Time is always progressing. The clock is always ticking. All right. So even though we can physically stop moving, right? We can stand still or we can stand in place. That doesn't mean time stops. So while there may be gaps in our distances, here and here, and we're not exactly sure what's happening in in those moments, time we can be sure of will always continue very consistently, 1 minute after the next. Now, if we were to graph this, okay, when you're creating a good graph, you have to start by creating two axes. Okay, and the one thing I want to just, make you aware of is that time is always going to be down here. Time is always on the bottom. Now, we call this bottom axis our x-axis, and we call the up and down axis, so this vertical axis, our y-axis. And that is going to be our distance in meters. And down here is going to be our time in minutes. Now, when you are graphing, you have to create increments on your graphs. So, increments are little lines that are evenly spaced that represent some value. And in this particular situation, we are going to have 0 minutes at first. And then because it goes up to almost 20 minutes, we could do increments of 2. We could do increments of 3. Okay, we could do increments of 4. Sometimes it's easier to do a smaller increment. So I'm just going to kind of think about this here. If I have 2, 4, 6, 8, 10, 12, 14, 16, not quite the number of increments I'd hoped for, I could always adjust those increments a little bit, make them slightly closer together. I could go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 2 minutes, 4 minutes, 6, 8, 10 minutes, 12 minutes, 14, 16, 18, and 20 minutes. Over here on the left-hand side, okay, I'm going to put my increments in for distance. Now, my top distance is 300 meters. So I may want to consider increments that will get me to the 300 meter mark that are easy to work with. And I think usually 25 is a good one. 10, 25, 50. So for our purposes, I'm going to try 25 here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are a little too close together. I'm going to spread them out a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now that's 2 spread out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we'll start at 0 meters. Then we'll have 25, 50, 75, 100. Now, as long as we allow every tick mark to be 25, we don't actually have to mark each one if we know what that is. So, for instance, I could go 150 here, 200, 250, 300. Okay? All right. Now, it's just a matter of taking the points that I'm going to highlight here and plotting them. Now, we can only plot points where we have data on both sides of our columns. So I need data both for time and total distance. So the points that I'm allowed to plot are going to be this first one and the second one, this one here, this one, and this one. These are the points I'm allowed to graph. So I always start by lining up with my time measurement, and then it's kind of like Battleship. If I say 0, 0, okay, well, I'm going to put a point at 0 minutes, 0 meters. And I'm going to check that off. Then at 1 minute, okay, so right here, in 50 meters, there would be a point. So 1 in 50. So I'm going to grab it, and I'm going to put a point there. I'm not going to connect my dots at first. Okay, I'm just going to leave the dots there. Now, at 6 minutes and 100 meters, I'm going to, okay, at 6 minutes and 100 meters, okay, so kind of right here, I'm going to have a point. So I'm going to put that point there. And then now there's kind of a jump, right? So we have to go up to 16 minutes and put a point at 150 meters. Okay, so sometimes a ruler is helpful if you're trying to get a line kind of, or you're trying to figure out where you're supposed to be going. So right up here to 150, I'm going to put our point there. Find 16 and 150 and put a point there. And then at 17, so just a minute later, it's going to jump up to 200. So there's a steep jump there. And then at 19, which is just a little bit farther, right? And I might even need to move my one dot over here just a little bit so that it's at 17. At 19 minutes, okay, we had a jump to 300. Okay, now I am going to connect my dots. Oh, I'm going to try to connect my dots here. Okay, so okay. And that is the graph of the motion of the person moving through the town. Now, believe it or not, this graph can tell us a lot of data. And, you know, as we're moving through this, if we need to pause and go back, I probably should have said this sooner, that is fine. If you need to slow down or whatever. But one of the things that we need to really mark on this graph, okay, is this idea that the graph tells us a lot about the data. First of all, this steepness, either here or here, is known as slope, okay? So this word slope is very important. It means how steep the graph is. And one of the things that's really important that ties in really well with yesterday's topic is this idea of whether something is speeding up or slowing down. And a steeper graph translates to faster motion, and a less steep graph indicates slower motion. Okay, so where the graph is really steep, like here, or here at the beginning, we would say that the object or the person was moving faster. And where the graph is less steep, here or here, then the object was moving slower, not quite as fast, taking its time, going for a steady stroll, not a sprint, more like a walk. Now, if I were to highlight the parts of the journey that were purple and yellow, we would see that these parts of the graph correspond to different legs of the journey. So, for instance, the steeper portion is at the very beginning here, and then there's a slower leg and an even slower leg. Then there's a steep, and then another really fast motion there. Okay, and if you were to stop and really think about this, Okay, purple is fast, yellow is slow. That makes sense. The person takes 1 minute to go 50 meters. Okay, now that's not a terribly long time. That's a jog. Okay, and then the person takes 5 minutes to go 50 meters. Well, that's really slow. That's a nice walk. Okay, and that might even be like a slow walk. And then 10 minutes to go 50 meters. Well, that's a crawl. I mean, that's you're planting each foot on the ground. I mean, that's taken forever, right? And then you do 50 in 1 minute and you're jogging again, right? Not a big deal. And then you continue to jog out through this last leg. So again, when you're first looking at this problem here, like this whole problem, you're thinking, okay, we're just kind of describing where the person is moving. But then once we start to collect some data here in a table, okay, then it starts to show some patterns, these breaks, like so. And then once you graph it, okay, now you've got a really clear picture of how this object's moving over time. And graphing data is really the essence of how you study its movement. That becomes a really important part of how we look at an object and what it's doing and where it is and whatnot. So again, steeper graphs relates to faster motion. Less steep graph is slower motion. Okay? Now, we are going to talk about one other set of ideas today. Okay? And we're going to visit this idea of graphing again, but we need to really talk about two terms today. And I want you to make sure you have these in your notes. And the terms are distance and displacement. All right? Distance is the total amount traveled. We'll talk about what that kind of means in just a second. And displacement is how far a person or object ends up from its origin. Okay, so if we're talking about distance and displacement, okay, it gets really, it can be a little confusing, but it isn't. It is simple. It's very, very simple. So let's say you have a person that travels this direction 2 meters to point A. Then they travel to this point B, another 2 meters. Okay. Then they travel back to A, 2 meters. Okay, so it's kind of continuing on here. We see this second leg is in red, and then this next leg is in blue here. And then the final leg of the journey, okay, I'm going to make this green, the final leg of this journey green. Okay, and they go another 2 meters back to B. So this would be like a person walking across the room and coming back halfway and then going back across the room. Okay, this is important. All right, if we were talking about the total distance they had traveled, okay, so total distance that they had traveled, we add up all of the legs of their journey, and that's how far they traveled. Okay, so 2 meters plus 2 meters plus 2 meters plus 2 meters is all the legs of their journey, and that's a total of 8 meters. This person traveled 8 meters. Please note that total distance is always positive. Okay? Now, our displacement today will be 2, but it isn't always. Displacement is how far the person or object has traveled from their starting point. So if the person started here and they ended up basically at point B, right? They might have come back, but then they've gone forward, okay? But really, they're at point B. they've really only gone 4 meters from their starting point. So the displacement would be 4 meters to point B. And one of the key characteristics that defines displacement versus distance is that there's always some sort of location information involved. I'm going to highlight that. There's always some location information involved when it comes to displacement. Sometimes that location information is east. Sometimes it's west. Sometimes it's up. Sometimes it's down. Sometimes it's left. Sometimes it's right. Sometimes it's forward. Sometimes it's backwards. Okay, let's look at another example of distance versus displacement. Okay, let's say that a person is, let's say some sort of creature. Okay, let's say some sort of creature, okay, travels to our right 3 meters, then turns around and goes back over here, okay, so that, okay, the green mark is going to be 6 meters long, okay, so this full green line here is 6 meters. Okay, and then, and we can call this, we will call this east, we will call this west, and then this cat, dog looking thing comes back east about just a little bit for 1 meter, and then stops right there. Okay. If that is the case, all right, if that is the case, then we have to look at, first, total distance. So again, this cat-dog creature went 3 meters, then 6 meters, then 1 meter. So total distance is easy. That's 10 meters total. Okay, no direction information, not important, just the cat went a total distance of 10 meters. However, displacement is going to be the distance that cat is from its starting position here. So this is the distance the cat is from its starting position. The distance from here to here. Okay? This is where it started. This is where it ended. And so the distance between those two is the displacement. So we don't really need to worry about too much here, other than we need to figure out what the distance between here and here is. Now, if the cat went 3 meters this way, and then 6 back this way, that means that this distance from here to here was 3. And then we came back 1. So the displacement is that the cat is approximately 2 meters to the west. So the displacement is 2 meters to the west. Where is the final position of this cat dog? And the answer is here at this red dot, and that's 2 meters to the west. Notice that I've included my location information right here. Okay, so this is how we work with distance and displacement, and we will be practicing clarifying some of these ideas next week. To review, this week we've learned about how we look at objects traveling as dots, whether those dots are like this, or like this, or like this. Okay, those dots tell us something about the motion of an object. We've learned that speed can be calculated by taking the distance that an object travels and dividing it by the time that it travels. Today, we looked at graphing motion and how when we graph it, it gives us insights as to how fast or slow an object is moving. And finally, we looked at distance versus displacement and what those two terms mean and some of their subtle differences. Next week, we will review all of these ideas as we work through some specific